Summer 25, paper 1-1, question 30. 2,5-dibromohexane is heated under reflux with ethanolic potassium hydroxide. So this will be an elimination reaction. 2-dibromohexane will form alkene. We are supposed to find how many isomeric compounds are formed with molecular formula of C6H10. We should consider both structural isomerism and stereoisomerism. Let's draw the structure of 2,5-dibromohexane first. In elimination of 2,5-dibromohexane, we will get different products because there are two bromine atoms here which we can remove during the elimination. And also the carbon that is bonded to the bromine, they have more than one neighbor carbon with hydrogen atoms. So if I remove this Br and the hydrogen on the carbon on the left, a double bond will be formed between the first two carbon atoms. So the hydrogen here remains. Then we have one more bromine here. I will remove this bromine for the elimination and also one hydrogen from the carbon on the right. Don't worry about the hydrogen on the carbon on the left first because I'll do it in the other product. So let's draw the complete structure of the first product. Right, this is the first product. We should consider stereoisomerism. I will check if this product has cis trans isomers. So these two carbon, this carbon is bonded to two hydrogen, no cis trans on the first double bond. The second double bond, this carbon is also bonded to two same type of atoms, which is hydrogen. So this first product has no cis trans isomerism. So this is just one compound without isomer. Let's look at what could be the second product. For the second product, I will remove the bromine and still the hydrogen on the carbon on the left. But for the second bromine, I want to remove the hydrogen on the carbon on the left this time. So I remove hydrogen from carbon on the right. This time, I do it differently so that I get different product. Right, now let's look at our second product here. The left carbon-carbon double bond, no cis trans because this carbon is bonded to two hydrogen. But on the right-hand side, I have both carbon in the double bond bonded to two different groups of atoms. So this product has cis trans isomer. So cis isomer is counted as another one product. Trans isomer is another one product. Let's look at the third product now. So for the third one, I want to remove bromine and also hydrogen from carbon on the right hand side. So double bond will be formed between these two carbon now. For the bromine on the right hand side and also remove the hydrogen on the carbon on the left. This is the third product. The two carbon in both double bonds are bonded to two different groups of atoms. So the one on the left can show cis trans isomerism, the one on the right can also show cis trans isomerism. We can use the formula to find the total number of stereoisomers for compound like this. The formula is 2 to the power of n. N is the number of carbon-carbon double bond, okay, which can show cis trans. We have 2 here, n equals to 2. So 2 to the power of 2 is 4. Now this compound has 4 cis-trans isomers. Now why 4? Because we have 2, right? The one on the left and on the right. So the combination will be both left and right show cis arrangement, or both also trans, or cis trans, and then trans and cis. So why 4 is because of the different combination on both carbon-carbon double bond, the arrangement of atoms in space. But also this third compound, this third product is symmetrical. So that means the cis trans and trans cis isomer will be identical. And since they are identical, we conclude that this product has only 3 cis trans isomer. Now let's look at the last elimination that we can do with this molecule. This time I will remove bromine and hydrogen on the carbon on the right, the other bromine, and also the hydrogen on the carbon on the right hand side. So the fourth one will look like this. So this is the structure of the fourth type of product. But if you look carefully, it is actually the same as our product number 2. So these two products, they are identical. Since they are identical, okay, I can scrap this off so that we don't get confused. Now let us count the total number of isomeric products that we get from the elimination of 2,5-dibromohexane. 1 plus 3 plus 2 from here. So altogether, 6 isomers. The answer to this question is C.